Today, I'll be presenting on the Minamata Bay environmental disaster, one of the most significant cases of industrial pollution in history, and the valuable lessons we can learn from it. This presentation will explore how industrial development without proper environmental safeguards can lead to devastating consequences for both human health and ecosystems, and how these lessons remain relevant today. Today's presentation will cover 5 main areas. I'll provide background information on the Minamata Bay disaster, including its geographic location and historical context, then the health impacts, focusing on Minamata disease symptoms and patient statistics, present environmental pollution data showing the extent of contamination, explore the economic and social impacts and global significance of this disaster, including policy reforms and the Minamata Convention. This map shows the bay's location and the position of the Chiso Corporation chemical factory, which was established in 1908. The factory became the primary source of pollution when it began, discharging industrial wastewater containing methylmercury directly into Minamata Bay. The pollution mechanism was particularly insidious. The factory used mercury sulfate as a catalyst in acetaldehyde production of plastics. Manufacturing, this wastewater was discharged untreated into the bay, where the methylmercury, a highly toxic organic compound formed in the reaction, entered the marine food chain. Through bioaccumulation, the mercury concentrations increased dramatically in fish and shellfish, which were then consumed by local residents, particularly fishing families who relied heavily on seafood in their diet. This chart shows the link between acetaldehyde production at the Chiso factory and mercury levels in fish from Minamata Bay. As you can see, acetaldehyde production skyrocketed from 210 tons in 1932 to over 45,000 tons by 1960, a huge increase. The blue line represents acetaldehyde production, while the gray dashed line tracks mercury concentration in fish. You can clearly see the rise in mercury levels as production increased. By 1956, when Minamata disease was first recognized, mercury in fish had reached dangerous levels up to 16.5 parts per million, far above the safety limit of 0.4 ppm. Even after production stopped, mercury levels remained high in the bay due to contaminated sediment, but they eventually dropped in the 1970s after cleanup efforts. Minamata disease is a serious neurological condition. This bar chart shows the most common symptoms. Sensory disturbance and constriction of the visual field were observed among 100% of Minamata disease patients, impaired coordination among 93.5%, dysarthria among 88.2%, gait abnormalities in 82.4%, and tremor among 75.8%. The disease is particularly tragic for children, especially those exposed in the womb. These children were born with severe disabilities like cerebral palsy and mental retardation, showing that methylmercury can affect a fetus even if the mother had few symptoms. The pie charts show the distribution of Minamata disease patients. Geographically, 76.6% lived along the Yatsushiro Sea coast near Minamata, while 23.4% were from the Agano River Basin in Niigata Prefecture, where another mercury poisoning incident occurred. Occupationally, 65% of patients were fishermen or their families, who consumed large amounts of contaminated seafood. This highlights how environmental justice issues intersect with socioeconomic factors. The fishing communities, often poorer and more reliant on local resources, suffered most from the pollution, as their primary food source became toxic. When Minamata disease first emerged, the local government provided financial assistance for medical costs. By 2001, over 2,900 people were certified as patients, with about 144.1 billion yen in compensation paid out. The largest remediation effort was the sediment treatment project, removing 1.5 million cubic meters of contaminated sediment at a cost of 48 billion yen, $480 million at the time. The Minamata incident had a massive social impact on both the local community and Japan as a whole. Families were torn apart, with many suffering severe disabilities or losing loved ones. Children born with congenital Minamata disease faced social stigma. The slow response from the government worsened the situation, and it wasn't until later that compensation laws helped. On a national level, Minamata sparked conversations about industrial pollution and pushed for stronger environmental regulations in Japan. The Minamata disaster shows the need to balance economic growth with environmental protection. The short-term profits from Chiso Corporation didn't outweigh the long-term damage. It also highlights the lasting health impacts of pollution, with many still suffering from Minamata disease decades later. The cleanup was a massive challenge, and despite efforts, some damage remains irreversible. The global impact was also significant, leading to the 2013 Minamata Convention on Mercury, which aims to reduce mercury pollution worldwide. Finally, Minamata shows that recovery is possible today. The city has transformed from an industrial disaster zone into an environmental model, thanks to community involvement. Thank you for listening.